Good morning students, welcome to the session. In this video we'll discuss about the lab activity. In lesson 1, by using the mirror, so we have one lab activity. By using a concave mirror, when you place an object at different positions on the principal axis or on the principal axis, we'll get different types of images at different places. The same lab activity we have to do in lesson 4 by using the lenses. So in lesson 1, concave mirror is a converging mirror, and in lesson 4 we have the two lenses, convex lens and concave lens. So which lens is a converging lens? Convex lens is a converging lens. So we'll do that lab activity by using the convex lens. So now we'll discuss. So what is this lab activity? What is the aim of this lab activity? Observing the types of images and measuring the object distance and the image distance from the lens. Next, what are the materials required? A candle, paper. Paper means it is we are using as a screen. Convex lens. This convex lens we have to take it as a known focal length, and this is known as V stand. Measuring tape, to measure the distances from the lens to the screen or from the lens to the candle, we have to use measuring tape or scale. So these are the materials required for this lab activity. Next, procedure. So how to do this lab activity? For this, first you take one chart, one paper, big paper, or you select a table, flat surface, and on that table you arrange these objects, materials. First, on this table you spread with a white paper and you draw a scale. On that scale you place these objects. First, you take, this is a V stand. V stand is nothing but it has a gap like this. In this gap, you can hold the lenses, either the mirrors or the lenses. Next, and this is the screen. So why we have to use a screen? Because by using the screen, we can catch the images. Real images always we can catch by using the screen only. Next, this is the candle object. So when you place this candle at different places in front of a concave mirror, we get different types, we'll get the different types of images. That all the images, by using this screen, we can see, we can find out what type of images, whether they are diminished or enlarged or magnified images. So first, you select a distance of 60 centimeter. So first, whatever the distances we have to measure, that always we should start from the optic center. We should start from the midpoint of the lens. So here we should start. This is known as optic center. From this lens, we have to measure. Here, when you place an object candle here, from the optic center to this candle you measure. Then this distance becomes the object distance and it is represented by the letter U. Next, this is U. And from this optic center, suppose if you catch that image here at this point, when you place this white screen, then measure the distance from here to this screen. Then this distance become the image distance for that object. So like that you find out U and V values when you place an object. First, initially you place it at a distance of 60 centimeters and gradually you have to reduce it, place it to 50, 40. Like that you just 10 centimeters you decrease and you place that candle in front of the lens, and by using this screen you catch that image on the screen and note down the values in each case, and here that values you must write in the tabular form. Here you see, when you place an object at 60 centimeters, 50 centimeters, 40, 30 and so on. Next, where you are getting the image, that values you note down. And after getting focal length also you must find out. How you will get the focal length? Always here, whatever the, here see, whatever the lens we are taking, that we must take it as that focal length is known focal length we must take. So that focal length value is 20 we will get. Or otherwise we have one formula. We have one formula, that is 1 by V minus, see 1 by V minus 1 by U is equals to 1 by F. In the lesson 1, to find the focal length of a mirror, we have to use 1 by F is equals to 1 by V plus 1 by U. But here for the lenses, the formula is 1 by V minus 1 by U is equals to 1 by F. That we have the derivation, but it is given in the colored pages, so it is not necessary to learn. That's why I didn't explain. But to find out the focal length of this value, we have to use this equation for the lenses is 1 by V minus 1 by U is equals to 1 by F. So suppose image distance here you got it as 30. Then substitute the values. 1 by V minus 1 by U means 1 by V. V means what? Image is 1 by 30 minus 1 by 60. So simplify this, you will get F value. Finally you will get F value. So like that, in each distance you find out the F values. So in this lab activity, if you observe, you should get all the focal length value should be same or nearer to that value. If suppose if it is 20, so we are taken as a known focal length 20 centimeter. So you should get that values 20 or nearer to that. Suppose if you are not getting that values, then whatever the values you are getting, you take the average of those values. You take the average of those values, and that you will get a final value. That value is the correct for that is the correct value for the focal, to find the focal length. Why sometimes we will not get the values, same values? Because if we do not do this lab activity properly, if we do any mistakes, then we will not get values similar. Okay, next, from this lab activity, what you can find out, what is the observation? Means irrespective of the U and V, wherever you place an object, will get the image at different places. Both are at different places, but finally you will get the focal length values are same or nearer. Okay, this is the lab activity by using the convex lens. We don't have lab activity by using the concave lens. Okay children, now in lesson 1 we have the magnification. Always I am comparing the lesson 1 and the lesson 4, because while you are preparing for the exams you will confuse. So that's why I am comparing that mirror and the lens and I am explaining. Now coming to the magnification. So what is magnification? Magnification is nothing but we are comparing the sizes of the images with the size of the object. Once again, what is magnification? We are comparing the size of the image with the size of the object. So that comparison that we are expressing in terms of ratios, that we'll call it as magnification. So magnification means the image height by object height is equals to image distance by object distance. So this we can use in the problems. So this is about the lab activity.